The final law that we use to solve triangles in this unit is called the law of sines. And the law of sines is really easy to derive, but there are two different ways it gets used, and one of the ways is easy and one of the ways is not. So we're going to take the majority of our notes actually on that harder method. So all you need to derive the law of sines is your area formulas. And remember that your area formulas just had three different versions. AB sine C, 1/2 AB sine C. And the other two versions were the same thing, it just would depend on which sides and which angle you knew. So side A and side B meant angle C. So the second version said that if you knew side B and side C, you would have to do sine of angle A. And the third version said that if you knew side A and side C, you would have to do sine of angle B. Okay, so what we do is we take all three of those versions and we just do the same algebraic step to each of them. And that algebraic step that we're going to do to all three versions is we're going to divide them by 1/2 ABC. 1/2 ABC and 1/2 ABC. And what's going to happen is that in this first version, the 1/2s are going to cancel, the A's are going to cancel, and the B's are going to cancel. And so what we're left with is just sine of angle C on top and side C on bottom. The second version, the 1/2s will cancel, the B's will cancel, and the C's will cancel, and we're going to be left with sine of angle A over side A. And the final version, the 1/2s will cancel, the A's will cancel, and the C's will cancel, and all we'll be left with is the sine of angle B on top and side B on bottom. Now, this is the law of sines, but it's the law of sines with all three versions set equal to each other. We only ever do two parts of it at one time. And we'll talk about on our example which parts it is that we use. But the way that we use, or the way we prefer to use the law of sines is if we know two angles and a side of our triangle, then what we'll do is we'll use the law of sines to find the other sides. That's the best use of it. Now, real quick, you saw this on the law of cosines notes as well, but remember that a lot of this unit is all based in geometry. So when we have two angles and a side, there are two ways that that can happen. We could have two angles and a side that's not in between them, or we could have two angles and a side that is in between them. But anyway you cut it, we've got two angles and one side in our preferred situation. Okay, so this is how we would use this. The reason that we didn't say anything about finding the third angle is because you don't need trig to find the third angle. So this was side A, we're going to solve for it, which means that this is angle A. This is side B, we're going to also solve for it, which makes this angle B, which then of course by default means that that's side C and that's angle C. So the first thing we're going to do is we're going to find angle C. Okay, and we're just going to do that by subtracting. There are 180 degrees in a triangle. We take away the two angles that we already know, and we figure out that angle C is 50 degrees. So that angle right there is 50 degrees. And now we can use the law of sines. Okay, so we're going to use the law of sines to find our missing two sides, and then we will have our triangle solved. Now what we do is each time we use the law of sines, the first fraction that we use in this case is going to be sine of c over c, because what we're doing is we're choosing the pair that we know. We know angle C and we know side C. It's the only pair of an angle-ended side that we know. So we choose to use those as our starting point. And so that would be sine of 50 degrees over side C, which was 25. And we set it equal to the fraction for whichever part of our triangle we want to solve for. I tend to go alphabetically. So what I would do is I would do sine of angle A over side A. And angle A was known. Angle A was 110 degrees. And then the only part of that proportion that I don't know is that bottom right corner, that's A. And so this is now a proportion. And so I can cross multiply and divide to solve it. So I'm going to do just that. I'm going to cross multiply and divide. So A is going to be equal to, I multiply across, and I have 25 sine of 110 degrees, and then we divide by the third corner, so divided by sine of 50 degrees. Now when you type this in your calculator, you need to do it as 2 steps, or you need to be very careful with your parentheses to do it all as 1 step, because your calculator will automatically start parentheses behind every trig function, so you need to make sure you close them. And so if you've typed this into your calculator, and of course if you're in degree mode, okay, then what you should get for your answer is 30.67. And so side A is 30.67. Now what I would like for you to do if you're watching this is I'd like you to pause it, and I would like you to set up the proportion that takes sine of c over c again, because you always want to start with the pair you knew. And this time I want you to set it equal to sine of b over b, and I want you to solve for the final missing side, side b. So take a second and pause it and do that for yourself. Okay, so hopefully you paused, and so what you would have eventually ended up with had you plugged in all your numbers and cross multiplied and divided is you would have had that b was equal to 25 sine of 20 degrees over sine of 50 degrees. And then if you had typed it into your calculator correctly, you would get 11.16. And now the triangle is considered solved. The other thing you always want to make sure you do is you want to make sure you check the geometry of the situation. This is the largest side. It's across from the biggest angle. Smallest side's across from the smallest angle. So you want to make sure the geometry always makes sense once you've got your answers. Okay, now for the messy part of the law of sines. In geometry, you guys did an entire unit where you used the protractors that look like this. For those who don't remember which one was the protractor and the compass, so there's your protractor, and it had all your angles marked all the way around it, of course, and then your compass. And hopefully you didn't use the safety compass. Hopefully you used a compass that looked like this, had a little bar across it with a little dial right there, had a sharp point on one edge, and had a pencil on the other edge. And that was what you used to do triangle constructions. And when you did triangle constructions, they would give you information, like they would tell you an angle and a couple of the sides, or they'd give you a couple angles, and you would do all your measuring and draw everything to scale. And what would happen is you would run into 3 situations. The first situation is you would go to all that effort, and you would end up figuring out that 0 triangles could be made with the given information you were told to draw. And you're going to see an example of that here in just a second. The second situation you would run into is there would be only 1 triangle that could be created given the information you had. And the second, or the final situation rather, is that you would have two different triangles. This was the one that was the most common in your triangle construction unit. Now the issue was that when you started a problem and you were going into a problem, you never knew which of those three situations you were going to run into. And so it was called the ambiguous case. Or at least we call it the ambiguous case now because of the fact that you don't know which of these three situations you're going to run into. And as far as the acronyms go, it's abbreviated SSA. You've got two sides and an angle that's not in between them. Okay, so what would happen is this. You'd be in your triangle construction unit and then give you these three pieces of information. So you would draw a flat line that would represent the starting side of your triangle. You would put angle A here, and you would take your protractor, this one right here, right there, and you would line it up, and you would measure, and you would mark out here, a little hash mark out there where 30 degrees is, and then you would actually measure out that direction. So you measured the 30-degree angle, put the little mark, and then you would actually move out, whatever. If they told you B was 10, it could be 10 centimeters or 10 whatever that they told you to draw. Okay, and then they've given you side A. Well, remember, side A would be this side over here. It's across from the 30-degree angle. And so what you're trying to figure out is where side A would hit this side over here. Wherever it hit this side, let's say it hit way out here or something, that would tell you where to close your triangle off or where to finish drawing your picture. The problem is that with the information that you've been given for this problem, when you take your compass, when you take that and you put the sharp point right here and you start swinging the pencil around, you end up swinging the pencil around out here in outer space. Side A, when it's only 4 units long, is not long enough to even reach this other side. And so what you've just run into is this triangle can't even be closed. It can't be created. Okay? So what we can do is we can confirm that same notion algebraically without all the drawing and all the tools. The law of sines will tell us the same thing because we've been given a pair. We have the angle, we have the side across from the angle, we have this side, and if we'd been able to create this angle over here, if we'd been able to close this side off over here, it would have created angle B because it would have been across from side B. So we've got two pairs. So what we do is we set up the law of sines, and we do sine of angle A, which is 30 degrees, over side A, which is 4. And then we would set it equal to sine of angle B, that's that angle right there that we were trying to find, if it existed, over side B, which is 10. The problem, though, that you would run into is that when you cross multiply and divide, you figure out that sine of B is 1.25, or 5/4, which means that that sine value is bigger than 1. And that can't happen. You don't get an answer when your sine value is bigger than 1. So what that has just told us is what we had already determined algebraically. Angle B doesn't exist, which means there are 0 triangles that could be made with the given information. The second situation that you would have run into would have started out identically. You would have started by drawing your flat side. You would have put angle A over there. You would have measured 30 degrees with your protractor, so you would have put that little, tick mark out there again, and you would have measured out that direction. So here's 30 degrees, and you would have measured out 10 units again. This time, however, you notice that side A is a little bit longer. So you would put the sharp end of your compass here, and you would start swinging the pencil end around. So it would start swinging like this, and what would end up happening is that it would be just barely long enough to just kind of brush up against that line right there, and it would hit it in that one spot. And so what would happen is if you started here and you drew out to there, you've just created a right triangle out of the situation. Now in geometry you would have confirmed it was a right triangle because you would have taken your protractor and actually measured to make sure that this was a 90-degree angle right there. But we can confirm all of that algebraically as well. Because what would happen with the law of sines is this time when we set it up, so we're still doing sine of angle A, which is 30 degrees, over side A, only this time side A is a little bit longer. It's 5. And we're still figuring out what angle B is over here where we closed our triangle. So we're still doing sine of angle B over side B, which was 10. And this time when we cross multiply and divide, we get sine of B is equal to 1. It's perfectly equal to 1. Okay? And so there's only one angle that has that sine value, and it's 90 degrees, which tells us there's one triangle that can be created, and angle B ends up being 90 degrees. So it ends up being a right triangle. Okay? Now the final situation, the most common situation, is that you would start that same process. There's angle A again. You would measure out 30 degrees right there. And you would measure, of course, out 10 units, so B would be equal to 10 again. Here's your 30-degree angle again. And this time, side A is even longer. So what would happen is when you put the sharp end of your compass here and you start swinging the pencil end around, what would happen is it would generate this huge arc out here like this. And so what that means is that it's hitting your closing side in two places. You could close your triangle off right there, or you could close your triangle off right there. Okay? And what that means is that there's two different triangles that could be created from this. The first triangle, I'm going to go ahead and draw them like they're split up. The first triangle is this smaller triangle right here. Angle A is still 30 degrees. Side B is still 10. Angle B is this angle right here. And side A is still 6. Okay? The second one would be this large outer triangle, so it would look more like this. And so once again, angle A is still 30 degrees. Side B is 10. Side A is still 6. And this is what angle would be in that case, in that instance. Okay? And so once again, in geometry, you would have had to draw everything perfectly to scale, and then you would have taken out your protractor and you would have measured this angle and you would have measured this angle to see how big the two potential answers for angle B could have been. We can do the same thing algebraically, because this time when we set up the law of sines, we have sine of 30 degrees over side A, which is even longer. This time it's 6. And it would be equal to sine of B over 10. And so this time when we cross multiply, we would get sine of B is 5/6. The fact that it's smaller than 1 is what tells us we're going to have two answers initially. Okay, just initially. And the way we would find our first answer is we would do inverse sine of that 5/6 right there. And what we would get when we did that is we would get 56.4 degrees. Well, if you look at the pictures, for angle B to be 56.4, that would have to be this option right here. So this is what I'm going to call B option 1. And it was equal to 56.4 degrees. To get the other option for angle B, I'm going to do this over here. So I'm going to call it second option for angle B. I would have to subtract from 180, just like we did when we solved all of our other sine equations over the last few units. And so the second option, or angle B2, would be 123.6 degrees. Okay, and then once again, you always need to make sure you check the geometry of that situation. Okay, because let's say hypothetically, okay, so you might even want to write this down, but hypothetically, let's say that this answer right here had been something more like 20 degrees. Well, that means your second answer over here would have been 160. But 160 would not fit inside of a triangle with the 30 that was already there. And so that's why you always want to check your answers and check the geometry of the situation. Okay? The final thing that I wanted to cover is there's a handy table in our classes that end up accidentally being left on the law of cosines notes. But it's a reference table, and it tells you that depending on which given situation you have, what law you would use and what you would use it for. So when we did our law of cosines notes, the first example we did was side angle side. We had two sides with the angle in between. And in our notes, we just used the law of cosines to find the third side. But we could have also used the law of cosines to find one of our other angles. Now before I move on, just a couple, hopefully very quick comments about that. The first is, you notice it just says one of the other angles. That's because once again we can just subtract to find the third angle. And the other thing I want to note is that some people will use the law of cosines to find the third side, but then they will want to use law of sines to find the other angle. Anytime, huge, and I'm going to say this every day, anytime you use sine to solve for an angle, it's automatically the ambiguous case. That means you automatically have to go into it worried about, do I have 0 answers, 1 answer, or 2 answers, and then if I have 2 answers, do both of those 2 answers work, and if both of those 2 answers work, then which one is my actual answer? So whenever you have the choice, do not use sine to solve for angles. Okay? So you would still want to stick with the law of cosines to find that other angle. Okay? The other example that we did on the law of cosines notes was where we had 3 sides given to us, and we used the law of cosines to find any 2 angles in the problem, because then once again we would subtract to find the third. And then on today's notes, the notes I just did, the first example had 2 angles and a side, and what we used is the law of sines to find the other 2 sides. And the final situation is that ambiguous case that you want to try to steer clear from when you can, okay, because sometimes you don't have the option. And what you would do is you would use the law of sines. You would find one other angle and figure out which and how many possibilities there are for that answer, and then you would use however many answers you got to find your final side of your triangle. Okay, so that sums up the final method and when you know which method to use. So feel free to come in and ask questions if you need to. See y'all later.